Go ahead.
For a week.
We're ready.
Oahu and Kauai. Okay, this is calling to order the planning committee on 28th, I think.
Yes.
April 28th. Okay, roll call.
Good morning. Thank you for your patience. Vice Chair Ranjiv Kush,
Here.
Director Diana Mayer,
Here.
Director Matt Sampson,
Here.
and Chair Larry Russell.
Here. Okay, I need a motion to adopt the agenda.
So moved. Second.
Any comments on the agenda?
There are none.
Roll call.
Vice Chair Kush,
Aye.
Director Mayer,
Aye.
Director Sampson,
Yes.
Chair Smith.
No. Russell.
Oh, Russell. Thank you. Thank you.
It's been a tough morning.
Yes, sorry. Public comment on non-agenda matters.
There are none.
Okay. I need a motion to approve the minutes of the planning committee on March 24, 26.
So moved.
Second.
Roll call.
Vice Chair Kush,
Aye.
Director Mayer,
Aye.
Director Sampson,
Yes.
Chair Russell.
Aye. Got it right this time.
Yeah.
Thank you. Update on water main breaks in the distribution system.
Yeah, good morning, directors. I'm Darren Machado, the district's operations director. This is Mark Cadine, superintendent of system maintenance and support services, and Mark's going to present this item.
Again, as Darren mentioned,
It's not on yet. The red light comes on.
Again, as Darren mentioned, I'm Mark Cadane, Superintendent of System Maintenance and Support Services. I'll be presenting on the update on water main breaks in the distribution system.
Fog.
Did you say the fog?
Fog, P-O-G. It's what the volcano shoots out the road.
You know, it was raining so much. I mean, it didn't rain that much. It didn't rain when we were there, really, one day, but it was that week before when they were having all the flooding. So the volcano was very chill.
Yeah, that I don't like that place because of the sulfuric acid.
We stay.
It's great.
You're live, Larry.
Okay, here you go.
Wow.
That's probably me talking.
That's it with the arrows.
Or I could just click them.
Okay, it's not connecting with that, so I'm just gonna have to run it. I apologize. Yeah. It won't, it's up on theirs, but now it's stuck in there, so let me switch out.
Yeah.
Why this is not on? Maybe it was, there you go. All right, go ahead.
Okay, here we have update on water main breaks in the distribution system. So here we have an overview of this presentation. We'll start with notification and response, classifications for leaks, detection and repairs, operations and engineering prioritizing replacements, and then an overall summary of this PowerPoint. The image on the right shows a water main break of a 4-inch cast iron pipe, December 12, 2025. And you can see kind of the extent of the damage of what some of these water main breaks can allude to. That was a brick inlaid apron to a driveway, which had to be completely removed because the water main is directly underneath all those bricks. So that's after the water main was shut down or throttled down, and that's what entailed the response.
Are there many places in Belvedere where the mains aren't in the center of the road or near the center?
Where they're not in the center of the road? Yeah.
This one.
Yeah. Belvedere's a pretty complex island as you drive around. A lot of them could be in the curb and gutter area. Usually downtown in the flats are usually kind of in the middle of the roadway. But this one here happened to be underneath the apron of a driveway.
At least we didn't get the BMW wiped out with the rocks this time.
So some key considerations for water main breaks. So impacts of water main breaks extend beyond repairs and include customer outages, property damage, and environmental risk to aquatic life from discharges. So some key points for key considerations are the outage, extent, and duration. Some of the water main breaks may extend for an extended duration of time, affecting customers' water use. Some system impacts could impact some of our district-owned pumps and tanks. Multiple customers, so some of the larger jobs may, believe it or not have a big impact on customers. They may only be 1 or 2 service laterals affected, but there could be hundreds affected depending on where it's at in the system. Property damage. So you got property damage potential, both residential and business. It could be privately owned property where water gets into a garage and affects storage boxes of personal property. It could also be flooding in homes, in atriums, and entryways. The other key point here is chlorinated discharge impacts to nearby aquatic life. So direct discharges. Some of these main breaks, as you see the one on the previous slide from Leeward and Belvedere, there was obviously a significant amount of water that traveled down the street. So that can have an immediate impact if there was a nearby water.
So this is at that same house?
This is not. This is over here on Old Quarry Road. This was a sheared off fire hydrant.
Yeah, that's what it looks like.
Yeah. So, but even these can have, extensive chlorinated if there's a nearby waterway. So
I presume we use the hollow bolts on the
Yes.
fire hydrants. So
Yeah.
they
That's standard.
if you hit them, they shear off easier. Don't tear out the mains.
supposed to. I've seen them stay
Yeah, sure.
intact, but that's the intent.
The hydrant risers are also designed to shear off too. Yeah.
So here we have notification and response. So you have water main break reported by the public. First and foremost, I mean, there are eyes and our ears out there. They see stuff day to day. So they're usually our main reporter of water main breaks or street leaks or leaks that they need us to go take a look at. You also have emergency services, be it the fire department, police department, other utility companies. You also have SCADA alarm. So SCADA, be it the supervisory control and data acquisition, we can see there on that screen rate of change alarms for the storage capacities in the tanks. We can also see flow problems such as suction or discharge input and output from pumps as we're moving water along the system. And usually when we get an alert, we want to get somebody out there in the field to take a look at it. So we do have 24/7 distribution operators working in operations. And when a leak is reported or a potential main break is reported, they'll notify one of 5 utility system specialists here at the district, 24/7 first responders. Could be during normal business hours, 6:30 to 3. Could be after hours, middle of the night, on the weekend, holidays. The utility system specialists will then take that information, report out into the field of that location, and report their findings. It's important to note, and I'll note it again later on, that not all leaks that get reported are district leaks. A lot of the time it's consumer leaks. Particularly this time of year, we see a lot of broken irrigation as it starts to heat up. So from there, the utility system specialist will report their findings and classifies the leak to the distribution operator. So we'll get into leak classifications later on in this presentation and how they're defined and how they're responded to. If it is determined to be a district infrastructure leak, such as a district service lateral or water main break in and of itself, the field supervisor is then notified. And we'll get into the next steps with the field supervisor in the next couple slides.
We exercise the gates routinely.
Yes. So here you kind of see a response chain. So we'll get into the first 3 right away. The leak gets reported to the distribution system operator, to the water district. The utility systems specialist responds to the site, and the distribution operator or the supervisor is notified of the findings. Now, if it's a consumer leak and doesn't have anything to do with the district's infrastructure, the communication stops at the distribution operator. They report their findings. We have a leak at this address. It's a consumer leak. I met with the homeowner or business owner and told them of the fact. If it is a district leak, from there, the supervisor then will get notified of the findings. The job will get scheduled and repairs will be made. The image on the right shows one of 5 utility system specialist vehicles reported to a scene, securing the scene with cones, lights, and their available equipment.
And they all carry dechlor.
Yes.
I'm really not asking these questions for me. I'm asking for the board so that they kind of understand a little more about what we do.
Yeah, it's important to also note on that previous slide, this slide shows that every reported leak triggers a defined chain of actions that moves efficiently from detection to repair. This next slide here shows utility system specialist and distribution operator response. So you can see the response between the 2 classifications. So what this slide shows before I get into the individual parts is it shows a clear division of responsibilities and communication that is critical to minimize impacts, environmental risks, and liability during water main breaks. On the left-hand side there, you'll see the utility system specialist defined roles. They will identify the leak based on the call that comes their way from the distribution operator, whether it be a class 1, class 2, class 3 leak, and again, we'll get into those classifications later in the presentation, or whether it be a consumer leak where they need to report their findings. Their job is first and foremost is to secure the leak location. If it is a district water main break, we got to secure the location first and foremost from the public, from other vehicle traffic, and just make the scene safe. That's first and foremost, and ensure that it's going to remain safe. We'll also put out best management practices, BMPs that we call them. What that is that's a silt mitigation and dechlorination process that we try to dechlor the water and mitigate the amount of silt that could get into a waterway, be it a storm drain. And we'll get into those again later on in the presentation. There's a particular slide that displays that. Documentation, photos, and written notes. We all have cell phones. Utility system specialists have their cell phones. Everybody takes pictures nowadays. So we take pictures upon reporting to the scene. We take pictures during the duration of the work. We take pictures of the repairs made. So we have all the documentation that we need and any type of written notes regarding the progression of the job. All that comes into play when the work order gets created by the supervisor for documentation purposes for potential claims. And we'll be getting into that here in a minute. From there, we'll notify the underground service alert. So the utility system specialist during a normal working day will notify underground service alert 6:30 a.m. to 3 p.m. What underground service alert is, it's a notification that goes out to other underground utility companies, sewer, cable, telephone, PG&E, electric, and gas. And they come out and they mark their utilities underground so that we can kind of plan our dig based on the excavation, proposed excavation site. Now, all that is color coded. Power is red, gas is yellow, sewer is green, and so on. During after hours, after 3 p.m. and on the weekends and holidays, the distribution system operator will notify underground service alert for us. And that's usually nowadays done all online with a form online.
And that's called USA. You'll see it written on places. They'll mark the ground in white where the limits of the excavation are. You'll see that big USA out there. That's what that's all about.
After the underground service alert has been notified, the utility system specialist will request a repair crew and additional resources as needed. A typical repair crew consists of 4 staff plus 1 utility system specialist for a total of 5 staff. Additional resources as needed could, as you saw in the initial overview slide on Leeward and Belvedere, the extensive cleanup that we have to manage too as well. So we could have additional staff report to the scene to assist with the cleanup efforts. It could, as you'll see during a class 1 water main break here shortly, require a second heavy equipment operator just based on the excavation size and the work that needs to be performed. But all that happens with communication through the field supervisor, the superintendent, and sometimes the operations director. From there, the utility system specialist will send out a discharge notification. Key points on the discharge notification are time leak was reported, time reported on scene, time water main shut off, any additional notes, whether fisheries was responded, and any additional notes that they have on their end. So those are just some key types just for record tracking and documentation purposes.
We coordinate with the police too.
If we have to. Yes. Sometimes you'll go out there, utility system specialists will respond like that one on Redwood Highway. over near the truck skills right there, pretty busy section of roadway. What they'll do is the police and fire departments are very generous if they see one of our staff out there working to shut down the water main, and they will assist without question. From there, they'll communicate the type of work needed to the supervisor and responding utility crew leader. This is an important part in the communication chain. Be it they let the supervisor know what's going on. Our staff is pretty experienced in our 24/7 first responders to know whether or not we have a water main break or whether we have a service lateral leak, and that's based on their findings on reporting to the scene. But they will report that to the field supervisor so that they know the extent of the work that needs to be performed, and the utility crew leader can make sure that they have the right parts, staff, and tools needed to perform the work. On the distribution operator side, usually after hours, after 3 p.m., weekends and holidays, again, they will be the ones to contact the repair crew. We have a standby emergency response crew on call 24 hours a day, 7 days a week, which consists of your typical crew: a utility crew leader, heavy equipment operator, utility worker, a second utility worker, or an assistant utility maintenance worker. So a typical crew of 4. They will notify emergency services of road closure. So sometimes these water main breaks will impact the roadway. Sometimes you need to shut the road down and there's no access through to emergency vehicles, and we need to notify them so that they can come out to the site, look at it, and determine a detour. If we, sometimes we'll notify them if they can expect delays. If you have an emergency call out in this area, you can expect delay, but we can get you through within 5 to 10 minutes. So we will definitely coordinate with County Com and emergency services on that note. The distribution system operator will also notify fisheries program manager or ecologist if the water discharge enters waterway with aquatic life. We refer to it as fisheries notification. If it's an extensive discharge, if it's a hit hydrant, if it's near a localized waterway, creek bed, and it is a pretty significant impact, we'll definitely notify them. Field staff do have a map that details out specific areas throughout the Marin County and the district system that identify those areas within the fishery response area. So it may not be a very significant impact in regards to the water discharge, but because it's in that area, we may want to have it checked out just to say we documented it, and we have the information. Management notification if necessary. Management notification usually happens when there's a communication between the superintendent on call or superintendent during normal business hours and the operations director. Several factors are considered in the management notification. Impact. Where's the water leak? You'll see later on in the presentation a class 3 water leak in the middle of a 4-way busy intersection in downtown Centerville, Terra Linda area. What's the impact? How many customers do we have affected? What's the discharge? What type of pipe it is? What size is the pipe? What's the property damage? So there's several factors that come into play when you consider a management notification, and that's where we want to kind of elevate the response and the information that goes out so that everybody is on the same page and knows what's going on and has the information that they need.
Mark, quick question for you. Is there somewhere in that algorithm or that, I guess, that checklist about potentially public notification?
Yes, we will reach out to our communications. If there is an extended outage, we'll make a recording through our dispatch line. And when they call in, they'll get the recordings that has information on estimated water restoration, what's affected, where the leak is. So it will have some basic pieces of information regarding the job that they can get that too.
And if it's a large enough traffic impact, we do work with public safety on Nixle notifications to the surrounding area.
You should add on to that list, notify the appropriate director, because that's one of the things we frequently get the phone calls before the district gets them, because people know us in the territory. So
that's a great point. Thank you for that information, and we'll take it into consideration. Definitely. Beyond the management notification, we'll have the distribution system operator notify the district's claims adjuster for any property damage or potential for any claims regarding property damage, so that they can get a file going on their end. During property damage, flooding, personal private property damage caused by the water main break, we have a on-call 24/7 water remediation contractor that we'll contact, and they'll work directly with the superintendent on services needed in regards to air movers, dehumidifiers, and working with the homeowner on addressing their needs at that time, based on the damage. This next slide here shows the supervisor's response. The supervisor, upon notification, will assign the resources. Again, the resources could include a typical 4-person crew. It could include additional resources, be it an extra heavy equipment operator, as mentioned before. They'll create the work order for documentation. This is where all the photos that get taken by the utility system specialist, by the field supervisor, if they show up onto the job site, and the overall progression of the job site notes that are taken by the utility system specialist and utility crew leader for work performed get documented. The supervisor will make a job site visit. Not always the case, but pretty frequently the supervisor will make a job site visit, and that's either to talk to customers who are upset and kind of want to know what's going on out there. The other is to check in with staff and make sure that they do have the available resources to direct the repair, perform the repair, and that they're set to be successful in that job. They'll notify the local agency of the leak repair. We'll get into this a little bit more in a class 3 water main leak that we'll see later on in this presentation, but some basic points of notifying a local agency would be to file an encroachment permit, design and submit a traffic plan with a software program that the supervisors have access to, known as Envirion, and submit a site plan. That software program allows us to pull a map image and attach information blocks on that image to show the exact job site location, to show any traffic control measurements or measures, any detour signs, and just overall information for the local jurisdictions to tell them what we're doing and how we're doing it, and to get their approval.
How do the photographs get attached? Where do they get attached?
Where do they get attached?
Into the file. How do they get linked so they're usable besides being on somebody's phone?
So this field supervisor will usually do this from their desk, or they will get attached to the work order that's used for tracking and
So they
documenting.
email them to the district, or
They email them to the field supervisor.
Mark, at a break 3 a.m, probably there's no one at the cities to get. So how's that work?
So we have an understanding with the local jurisdictions that upon the field supervisor's arrival to work the next business day, that we will get that information to them right away.
Yeah. So we don't wait.
Thing in the morning. No.
Yeah.
No. And we have a basic understanding with local jurisdictions and towns, and they understand that.
Right.
So after the notification of the local agency, a work order packet could be created for the district's legal department regarding any potential claims. And this is where the creation of the work order for documentation comes into play. The field supervisor creates that. The utility crew leader puts notes on there regarding the progression of the job, materials used, staff time, and work performed. The utility system specialist will put documentation notes about their response. They'll fill out the appropriate forms, such as the discharge notification. And they'll put the photographs again on the work orders. And usually if there's a potential for claim or if there's property damage, we'll touch base with the legal department and we will send them a work order packet so that they have all the information related to a potential claim or an obvious claim coming their way, and they can look through the information and reach out back to us if they need any additional information. When the leak repair is completed, the supervisor will send a street opening, which is basically a form that has information regarding the size of the hole, the AC thickness at the job site, the concrete work that needs to be restored to the district's paving coordinator. From there, the paving coordinator will work with a contractor on compaction testing of the subgrade material used to backfill the hole, and final paving restoration with the district contractor as well too.
And then
How many
Director
of these-
Russell, oh, go ahead.
how many of these a year?
We'll get into that. We have a slide later on in the presentation that has the exact numbers of 1, 2s, and 3s and total numbers going back 5 years, back to 2021.
Cool.
And then one thing to answer your question to Director Russell regarding the photos, like when you open the actual work order, it'll be linked to this specific repair. And there's an attachment list. So on that attachment list is where you'd find the photos and a copy of the encroachment permit and other documents that you'd want to link to this work order.
Thanks, Derek.
Yeah.
Best management practices, we refer to them as BMPs for short, for chlorinated discharges. So the image on the right, you can see some gravel-filled sacks put in the path of the waterway in a curb and gutter area. And you'll also see some of the gravel filled bags surrounding a storm drain inlet and also a orange storm drain inlet cover. This is used for sediment and erosion control. Again, waddles in the flow path of the water, storm drain swales to slow the flow of the water, and the cover over the storm drains. Also, you'll see in that image, just right at the split between the two gravel filled sacks before the orange storm drain cover, dechlorination tablets. Those are hockey puck sized tablets, sodium thiosulfate. And what it is used for is to come into contact with the water and to help with dechlorination of the water before it enters waterways and storm drain inlets.
Where does the water go when you cover the inlets?
It's able to travel through that mat.
I see.
And it depending on the area where you're at through Marin County, if you're next to a waterway, a creek, a known creek, you try and track it down the street or towards that waterway to kind of see if you can see where it goes.
You might recall that we were fined almost $250,000 by Fish and Wildlife about, I don't know, 15 years ago for illegal take, because we captured the dead fish and put them in the freezer, and then they told us we took illegal take of the fish. And so this is serious stuff in terms of what consequences of release of the chlorinated water into freshwater bodies.
Yeah. For dechlorination, again, we have hockey pucks size dechlorination tablets, which are sodium thiosulfate, which assist in dechlorinating the water. The utility system specialists also, to your point mentioned earlier, dechlorinating diffusers. They carry these on their trucks, their first responder vehicles, and they attach these to fire hydrants, and it has a chamber where the sodium thiosulfate tablets get inserted, and when they're flushing out water mains, the water comes in contact with them, and it helps in the dechlorination process as well too.
Does the fire department carry those too? Because I know they access the fire hydrants, right?
I'm not sure if they do.
I don't think they do.
We also have small pea gravel sized granules that we can disperse and throw out in the path of the water travel that dissolve on contact with the water to assist in those dechlorination efforts as well too. So we have a couple of different choices that we can use. Here we have leak classification categories. So we have class 1, class 2, and class 3 leaks. So the district prioritizes water main leaks using a 3 classification system that's based on impact and severity. This helps guide response urgency and repair timing. Class 1 water main leaks are access to drinking water is impacted and a main line must be shut off. Those are our most severe ones. Class 2 water main leaks, the service is not impacted due to the leak, but the leak will be managed based on available resources. Now, it's important to mention these class 2 leaks could be repaired the same day, depending on further discussions on impacts, potential impacts, what's the infrastructure that's leaking. So those could be repaired the same day. Class 3 leaks, the leak is very minor and the water loss is estimated to be low. The leak will be repaired within a 2 to 3 week period, depending on other priorities. Now, it's also important to mention the class 3 leak could be elevated to a class 2 or class 1 to be repaired that same day, depending on potential impacts, what's the infrastructure that's leaking, and what is the overall potential of this leak. But again, that would involve further discussion with staff.
Was that Belvedere pipeline on the radar? Was it one of the ones to be replaced?
In regards to the capital,
Well, yeah, we have that ranking of potential leaks or bad spots.
no, that water main break happened all by itself, unknown.
And it was the normal thing where it splits along the top.
Correct. This one actually split on the bottom.
Mark, on this slide here, I think we just paused for a second because a lot of the times I get questioned about, hey, there's a leak. I reported it a week ago. No one's come out yet. And not understanding how the system works. I wonder if there's a way we could actually split this up or make this aware for folks that are actually reporting leaks so they understand that there is thought going into it. It's not just, hey, they blew me off and they didn't get to my project or whatever the case may be. Because understanding how we prioritize things with crew availability, risk potential, and all those things would be, I think, pretty valuable for the public.
That's a great point, and we'll take that into consideration.
Well, why don't we close the loop and have somebody call back the person that called in?
We usually do.
Okay.
We usually do we'll have the field supervisors reach out during the day if it's a leak that's reported multiple times and the customer has questions. We'll have the field supervisor reach out that same day, shortly after the initial phone call, and let them know what's going on and let them know that we'll send staff out there again today just to reclassify the leak and take a look and make sure nothing else is getting worse. Yeah, so we do address it same day. Here we have a class 1 water leak, January of 2026 of this year. So the image on the left shows a firsthand photo from the front windshield of a utility system specialist first responder vehicle as they reported to the leak location, a water main break location. You can see the water discharge from the 8-inch cast iron water main break at this location. The image on the right shows staff excavating the hole. You can see we needed additional staff on this water main break to excavate the hole, be it 2 heavy equipment operators and additional field staff to assist in the cleanup.
Those are our excavators?
Yes. So it's important to mention to this, and this will play into the second class 1 water leak that we'll see in the next couple slides here, that this water main break happened Monday evening, unreported, and it was the first of 2 that were reported that same evening. There were a total of 18 staff that worked on this water main break through the night into the next day, with the first initial reporting staff of 7. That first initial crew that responded was replaced by a staff of 5 at 2 a.m. in the morning. And then at 6:30 the following day, a staff of 6, crew of 6 came out to relieve that crew. So in total for this job right here, there were 18 total staff that worked on this throughout the night. The image on the left shows a small section of the broken 8-inch cast iron water main that was removed out of that hole. You can see a complete side of the pipe is missing. In total, staff installed 26 feet, 4 inches of 8-inch PVC C900 pipe, as you can see in the image on the right. So not only did it blow out a small section of water main here, but the break actually traveled beyond that, and a 20-foot section of cast iron pipe split beyond that. So we need to remove a whole nother 20-foot section of cast iron water pipe to make this repair. And you'll see that the pipes don't necessarily line up in a straight line. So we have a universal dresser coupling in the middle of that repair with some thrust balking in regards to the deflection.
Mark, do we know how old the cast iron pipe was?
I do. It was installed in 1960. So sometimes we see a small section and it travels beyond, the bell and spigot and gets into a whole nother section of pipe, and we got to make some pretty extensive repairs.
One of the questions I had, this is raising it for me, is when you have these kinds of leaks, is it usually in places you expect, like where something hasn't been serviced in a long time, or is it just seem to be unavoidable, like it might be a brand new pipe?
Honestly, I was a utility system specialist here at the district for 8 years, and in my experience at that time, there could be 100 reasons why these water main leaks appear. And if we knew where these were going to appear in our pressurized system, we would try and do what we could to address it.
Sure.
But usually these ones happen and they just happen.
Yeah.
No, Addie, it's usually not newer pipes.
One last question on this one. You said this was unreported. Is this something the SCADA system would have alarmed about, an 8-inch like that?
Could have with the rate of change. Yeah.
So rate of change from a tank, can you explain that?
So on the SCADA screen shown earlier in this presentation, you can see the individual storage tanks on that initial SCADA reporting screen. And all those say a set level. They have a high level, they have a low level, a low level. So we know the level of the tank and the percentage of that tank. So if that tank is just dropping and losing a lot of water rapidly, that rate of change alarm will come up and it'll tell us that there's a problem with that tank. Sometimes it'll get reported by the public as soon as we notice something like that. Sometimes it'll get reported by county comm, but it's a rate of change flow alarm in a storage tank with the output of the tank. That's beyond normal conditions for what that tank should be doing.
It's interesting. The pipe on the left almost looks unused. You know, there's no corrosion at all inside, or very little. I don't know what that brown spot is there by the break, by the second break, the rat bite
Mhm.
next to it. But there's no discoloration, no rust. It's good.
So here we have another class 1 water leak. So that same Monday evening, just shortly after the initial one was reported, just up the road on Channing Way, there was a second water leak that was reported that turned out to be a class 1 water main leak. This one was on a section of 12-inch steel pipe that broke. In the image on the right, you can see at a weld joint. So that same night we had the one, and then we had the second one a couple hours after that. And the image on the left shows after we excavated the hole, you can see some of those underground utilities in there that get marked up by the underground service alert, the USA notification. So yeah, shortly after that, this leak happened right here. So we needed to call out not just the initial staff, on-call staff to report to the Redwood Highway water main break, but we needed to find a totally separate crew to address this leak once it was pinpointed and identified as what the issue was. So this leak here, we were able to get a crew of 5 to respond in the middle of the night, unannounced, to start repairs on this water main and make the excavation and expose what's leaking. That crew was replaced by an additional staff of 4 at 6:30 the next business day. So that initial staff unannounced got called middle of the night, worked through the night till the next day, to make repairs to this water main.
So just to clarify, Mark, there were these 2 events that you've just walked us through were happening almost simultaneously.
Within 2 hours of each other.
So we had crews for each of these.
Yes.
And when he's saying unannounced, there's a certain number that are on standby any given day that are sort of planning to be called in. But once those are exhausted, you're kind of making cold calls to see who may be available.
And Director Sampson, back to your point regarding using SCADA, like some of the breaks we'll see on SCADA immediately. Some of the larger systems, we may not see it. But we will go back and in a situation like this where we had 2 main breaks on in the same pressure zone, we'll go back and look at SCADA the next morning to see if it was coincidental or if it was some sort of system issue, a pump shut down too fast, a regulator issue, a hydrant was being flowed and got shut down too fast, some sort of water hammer created. But we will use SCADA after the fact to go back to see if there was something that happened system.
Almost like a postmortem.
Yeah.
It's interesting. There's been some media coverage lately about East Bay's water infrastructure and a leak correlation with earthquake movement. And so it'd be interesting to see if that plays in at all. I don't think we've had anything big in January, but that's what East Bay is looking at right now in some of their water leaks.
Interesting. One other point between that leak on Channing Way and the one on Redwood Highway. So within a 24-hour period, we had 27 staff respond. And that's great. It shows, reliable work staff, and it shows commitment from our staff within departments. So across 3 different departments, system maintenance, facilities maintenance, and project maintenance, we had 27 total staff respond within a 24-hour period.
If someone's on standby, do they stay within a certain radius? Like are they supposed to not book anything during that time? How do you ensure that people are available?
So we schedule the standby.
Okay.
It's a voluntary list that staff sign up for, and they're assigned a week. So they know in advance when their week of standby is coming up so that they can make accommodations on their end with their family and events that they have going on. They can also trade. They can also swap weeks with other staff. If they have something that suddenly shows up, you work with the other staff and you find a replacement.
So, but if they are on standby, they're expected to pick up the phone and be able to.
And they get
respond.
paid, right?
Yes.
Yeah.
There's
Okay.
compensation
Just want to make
associated. with it.
sure.
Yeah. So they have set schedules that they do. And depending on staffing level within a certain position, you could be on once every 5 weeks. You could be on once every 4 weeks. You could be on once every 8 weeks. It just depends on what position you're in, but they are scheduled out, and it's an entire year schedule that gets put out. So they can know, right now, today, their standby week in December.
Do we
Around the
consider how
holidays.
far away they are, how far away they live?
Yeah, we take a look at that. They should be, within an hour of response time. So here you see, this is an animated slide here. So this is an active Class 2 water leak on Kent Fire Trail Road in Kentfield on a 24-inch welded steel pipe transmission water main. This was recorded by the utility system specialist upon arrival to the site. And this was in October of 2025. So again, as mentioned earlier with the classifications of the leaks, depending on what the Class 2 leak is, what is the pipe that's leaking, develops into further discussions on whether or not repairs are made that same day or whether or not it could be scheduled. Now, this is a pretty popular area for hikers, bikers, dog walkers throughout Marin County. So this Class 2 water leak, we responded to the same day. I think within about 2 hours, we had staff out there on site to begin excavating and finding out what the infrastructure is that's leaking.
Any fish kills on that one?
No.
Quite a bit of water.
Quite a bit of water. So here you see where staff exposed a 24-inch pipeline access hatch. That's what we exposed, digging up the leak location. Just below that access hatch, there's a 3 to 4 inch split on the side of the pipe just below that hatch. That's what we exposed, and that's what was leaking on the side of that pipe.
What is that hatch for?
Inspections,
I mean, 24-inch, a little tough to get into.
a little tough to get into, yeah. I'm not going to get in there. So the image on the left shows after the planned emergency shutdown and draining process, the small crack in the side of the pipeline just below that access hatch. And the image on the right shows the welded patch plate repair performed by the district's welder fabricator. It's important on this particular repair, we were able to plan what we call an emergency shutdown. So once we exposed the leak, determined what was leaking, we looked within the system, like what is it going to take to shut this water main off? So the distribution system operators, just to kind of walk you through some of the process, they early filled 12 storage tanks throughout the system. There were 23 water valves utilized during this shutdown. 6 pump stations and 5 regulators throughout the system were affected. There was reduced fire flow to small areas within the system. Confined space issues. We can reroute water through the Ross system, through Federal Works and to the Alto tanks to supply Southern Marin. But in total, there's a lot of individual steps that need to happen. So during the shutdown process, 1 utility system specialist and 1 mechanical and electrical worker, from the time they turned the first valve, it was 13 hours until the pipeline was drained. Upon turn on, 2 utility system specialists and 1 mechanical and electrical worker took them 10 hours from the time they started to charge the water main till it was fully turned on. Throughout all of this, the most important fact, no consumers were affected. Everybody had water. In this instance here, we were able to plan this emergency shutdown with coordination effort across a variety of departments within operations. And you can see the result there that we successfully repaired the water leak on the side of the pipe. We also notified other departments to come out and inspect the pipe, be it our corrosion department and our engineering department, to come out and take a live look at the pipe and infrastructure within the ground that we exposed.
Can you just say what confined space issues are?
So
Does that
confined
mean you
space,
couldn't confine it to a certain area?
No. It's a worker safety.
it's a safety protocol that we have here in regards to entering confined spaces. And some of our valve pits and some of our regulator pits are in-ground redwood framed boxes, if you will. And we need to get in those confined spaces and perform the work. And there's a variety of safety steps that we need to take, such as air monitors, blowers. You need a secondary attendant there with you, just in case something happens. So it's not necessarily kind of a confined area like you're working underneath a tree and it's kind of a small area. No, it's getting into the ground and working. So, if that answers the question. So here we have a Class 3 water leak on Larkspur Landing Circle right over here, October of 2025. So you'll see that there's a visible water leak in the roadway. This took a coordinating effort with our water system technicians in our leak detection department. to identify and pinpoint the leak's location. We used acoustic listening devices, correlators, and leak loggers to listen on the section of water main, either between a service and a valve, or a hydrant and a valve, to encompass the area where we suspect the leak is coming from. That gives us a pinpoint area, kind of a broad range area of where that piece of equipment is telling us, like, you have a leak right here. It's 10 feet from this valve. It's 15 feet from this fire hydrant. We took it a step further, and you can see the image on the left there. If you turn your head to the side, you'll see the word test holes. That's a common method that we use to actively, visibly pinpoint water leaks. The circle in the middle, the circle dot in the middle, indicates where all of our acoustic listening equipment puts the leak location. And what we'll do is we'll go out there and we'll drill anywhere from 1 inch to 2.5 inch diameter holes through the AC, and we'll put steel listening rods down into the ground, come in contact with the water main, and we'll listen with our own ear for the water leak. We were able to accurately pinpoint this leak with those efforts, and you can see what we exposed in the ground, be it the 16-inch water main and the picture on the right with multiple leaks attached to it.
What you probably should explain to them is where the water comes up is not necessarily where the water is coming from. That's the trick. Is it come out of the seam, for instance, like where that's been repaved, it might come out of the seam, even though it's 25 feet away where it's actually leaking from.
Yeah.
The confined space, there's other, safety, right? This potentially dangerous work.
It's all safety.
That
Yeah.
it is all safety, the response, and first and foremost. So you think about confined space where you have limited access and egress. You think about shoring. So sometimes you're just digging in the soil, right? If it's a certain depth, you have to secure it with different materials so it doesn't collapse on them. And traffic is huge, right? This is in the middle of the night, could be raining, so you really need, and then of course the marking, but the PG&E gas lines, right? Definitely goes through your mind big time. So there's a lot of considerations, and really it's safety is foremost. And
Yeah, I've worked enough in the road. One of the problems is you start to think you belong there, like the cars, because you're doing something. So you're really focused on what you're doing. And that can be really dangerous, is when you think that you have priority because the car is doing what the car is going to do. And they'll try to avoid you, but, not always.
Yeah, and just to go back to your point, Director Russell, in regards to where the water is actually showing up and where the leak is pinpointed, a lot of people, the common sense thought is that water travels downhill. Well, it doesn't. It travels uphill.
Sure.
So there's always that thought. But yeah, that is a great point.
It looks like this pipe's been kind of active corrosion for a while, looking at it. Is it cathodically protected?
Yes, it is.
That's interesting.
There's an anode well rectified system over by just after the off ramp over here for 580, right there on the corner. Yeah.
Any idea why it failed?
No idea.
Is it leaking from the inside or from the outside?
I would say leaking from the inside.
Well, leaking from the inside, but it's corrosion from the inside or from the outside? Because it looks pretty banged up to me from just looking at that surface.
Knowing that area, I'd probably say corroding from the outside.
Salt water.
Yeah. Just that environment over there. So here's the continued repair efforts on this Class 3 leak on this 16-inch welded steel water main. You'll see a staff member inside of the excavation using a newly purchased tool that we purchased back September of 2025. That's known as the Walks Diamond Wire Rope Cutting Saw. What that is, it's got a diamond rope attached in the saw. It clamps over the top of the pipe and can cut pipe ranges from 4-inch to 16-inch. So shortly after we purchase this piece of equipment, we get to use it at its max effort. It provides definitely a safe, reliable cut for a section of pipe. When you consider other methods that other utility companies or that we've used here at the district, other pieces of equipment we've used to cut pipe. There's always the potential for some danger.
Around the pipe.
So it straddles over the top of the pipe, and the rope goes over the top of the pipe this way.
And it cuts down.
Yeah, and it cuts down. So the staff member there you see cutting the pipe, he has a hand crank that he's driving that wire rope saw through the top of the pipe.
So it's kind of like a chainsaw with a diamond rope.
Yes, like a guillotine saw.
And this is shoring on the right. That's a
Yeah.
good example.
Yeah, so to touch on what General Manager Bennett touched on just a little bit ago regarding the shoring and the safety of staff. So the overall excavation on this job was 5 feet 4 inches into the ground to the top of that pipe. The overall excavation itself, when you consider repairs that were needed, we needed access to the bottom end of that pipe. So that hole was 7 feet plus in depth. So what we did was we utilized the district's hydraulic shoring jacks. We utilized the training that has been
Which are
provided for
those?
staff.
Those pipes you see there.
Yeah.
White ones.
We've utilized the training that's been provided to staff so that they understand competent person training, shoring, trenching, and excavation. And we installed those shoring jacks against sheets of plywood to shore up the hole. And what that is that stabilizes the walls of the hole to provide a safe working area for staff to enter the hole and perform repairs.
And OSHA requires these after 5 feet.
Mm.
Because you can't get out. If it collapses, you're not probably going to make it if it's deeper than 5 feet.
So the repairs on this 16-inch welded steel water pipe involved a new 6-foot section of Schedule 40 16-inch welded steel water pipe and 2 butt strap weld fittings to repair this leak.
It doesn't appear the pipe is wrapped.
It's wrapped after that. That was taken prior to the pipe being wrapped.
That's the repair.
Yeah, that's the actual repair itself. But we do wrap it. So here's another example of a class 3 water main leak in the Terra Linda area of San Rafael that I mentioned earlier in this presentation. Leak repair coordination and permit process. Here we have a detected class 3 water main leak at Las Colinas Avenue and Northgate Drive in San Rafael. We know that it's an 8-inch cast iron water main running through the 4-way intersection. It's also important to mention here that just east of this photograph, not too far, maybe 2 blocks down the road, is Highway 101. So it's a pretty busy area. This leak was minor and the water loss was estimated to be low on this water leak. And again, to Director Russell's point, you can see the water showing up on both sides of that intersection. But if you look at the photograph there, I drew a blue dotted line. That's the actual location of our 8-inch water main. So you can see to that point that the water doesn't always necessarily show up where you think the water main is. There was definitely some potential impacts from this, be it in the busy 4-way intersection next to Highway 101. And there was significant coordination between the city of San Rafael that we'll get into here in the next couple slides. So this slide here is going to show some work that had to be submitted to the city of San Rafael to perform this work. So here we have an encroachment permit, which is filled out by the field supervisors and submitted to the city of San Rafael.
And you can do this because it's a class 3, not if it's class 1, you just go, right?
Class 1 we go, but we still do follow up and send all the required forms and paperwork to the jurisdiction. So here we have, we're going to go through several different forms that had to be submitted through the city of San Rafael to be able to perform this minor leak repair known as a class 3. So we have, first and foremost, we have the encroachment permit. Next, we have a site map. Now this site map is generated from our GIS software that we use program. We take a still image in the Google Live Map view of the area to be worked on. And through the Invariant software program, we're able to attach boxes on here that explain what it is that we need to work on. They can see exactly where the site is located. They can see the work site area. It's also important to mention here, not only for the visible water location that's showing up for the leak, but also you'll see on here the purple line. That's a reclaimed water line. So we had some complexities in determining what exactly was leaking in the middle of this intersection. So we got our leak detection department involved. We did a planned shutdown, a quick planned shutdown that involved 2 valves and 1 service that fed a gas station. So we wanted to determine whether or not it was on the reclaim line or whether it was on the potable line. So we shut down the 8-inch cast iron potable line first and foremost, and the water flow stopped 10, 15 minutes after the shutdown was done. So we confirmed which pipeline it was on. And the green area in the middle there shows the exact job site location in the middle of that intersection.
Of course, at this point, you still don't know where it is.
Still don't know where it is.
You know which line it's on, but not where it is.
So we used the acoustic leak detection equipment. We also used the test hole method on the day of the excavation to determine the exact location and pinpoint it. So here you'll see, again, utilizing that Invarion software program, the traffic control plan that gets designed by the field supervisors in accordance with the MUTCD. And on that shows delineation with the cones that you can see in the highlighted yellow areas with the orange dots, be it the road cones. You can see the road work ahead signs, lane shift signs, road work ahead signs. Any sign is deemed necessary to perform the work in the middle of this intersection. And upon designing this traffic control plan, once it's submitted to the city of Santa Fe, we need their approval with it. They may want us to change something. They may want to add a sign. They may want to submit another form. So here you'll see a detour map that also needed to be put together. So you can clearly see on here the location of Highway 101 and the close proximity to this job site location. We needed to create, the city of Santa Fe wanted a detour sign because the traffic coming from the four-way intersection isn't going to be able to travel through the intersection. Everybody is going to be turning one way or the other. You're not going to have a straight travel path through that intersection with the job site location. So this dictates what our detour plan was, where we're going to put our signs, and how traffic is going to be detoured around that job site. Here you'll see some additional information that we submitted based on the MUTCD. We have lane shift information. How are we going to shift traffic? What signs are we going to use? How is it going to be delineated with cones? You'll also see sidewalk detour for pedestrians.
Mark, how long did this fix take?
We 9 in the morning till 3 o'clock that day.
Wow.
Yeah.
Pretty fast.
Yeah. And the city of Santa Fe and the coordinating efforts gave us that timeline. They said you cannot be in the middle of that intersection prior to 9 a.m. and you need to be out of there by 3 p.m. So the importance of taking the extra time, performing the test shutdown, using our acoustic leak detection equipment to pinpoint that leak. We got a limited time to get out in the middle of this busy intersection and perform the work. Because after 3 o'clock, that intersection is going to get very busy. So using all of our resources, using all of our tools and available equipment, and being safe at the same time. Again, safety comes up, working in the middle of that intersection. This is live visuals of it. And these next two slides are going to show some actual drone footage shot by the district's drone operator of the job site before we get out there and of the job site while we're actually performing the work. And you can see the impacted traffic and how we set up to perform the work. Now, again, you can see the water locations on both sides of that intersection. We're working right directly in the middle of that intersection. And you can see, and here is the drone shot. You can see the traffic flow through that intersection. Now, this is the morning. This is prior to 9 o'clock and us getting out there. So you can kind of just see, and it will pan over to a nearby parking lot where we have district staff staged. They had to show up with the signs. They're actually out there right now on the sidewalk, setting up signs, putting cones in particular spots to be able to get out there, set up our traffic control so that our crews can get out there in that intersection and repair that leak. So there's our district staff in that parking lot, getting everything ready to deploy. And you can just see kind of the traffic impacts that this has a potential to have. Also working with the city of Santa Fe, a company, DC Electric contractor, had to disable the traffic loops for that intersection and turn all the four of the traffic lights there to the blinking red, just to help the congestion of traffic. So here you can see a live footage of our district staff in the middle of that intersection, not only utilizing our traffic control methods, but utilizing district vehicles and equipment to protect staff in the middle of that intersection. So we have, down at the bottom, we have a utility crew leader truck parked in that lane, assisting vehicles to make that right-hand turn. We have one of our dump trucks in front of that. We have our system maintenance service truck. We have our small dump truck on one end, and you can kind of see kind of the path flow of traffic, live visual from this drone footage of us actually out there performing the work.
It's interesting though, no cops, huh?
Mhm.
So here you'll see the three images of that leak. So the leak on the 8-inch cast iron water pipe, you'll see the image on the left. That's what we exposed as leaking. The image in the middle, we have an 8-inch by 20-inch full circle leak clamp that we typically utilize to wrap up these leaks and fix them. And then the image on the right, through the pinpointing efforts and the leak location, is a 5-foot by 10-foot patch when we left that intersection. So the operations and engineering prioritizing main replacements. So last April 2025, I believe it was April 29th, 2025, operations and engineering developed a folder, a project folder. So this folder is pipeline projects operations would like planning and design to consider prioritizing for replacement. It allows engineering to design top priority pipeline projects with operations input, and it assists in developing capital improvement programs in the future, provides flexibility to pivot on projects based on reprioritization. The submitted projects information included in those folders is the cost of repair and restoration costs, the age of the pipeline, the location, property damage potential, and condition of pipe when it is exposed. Operations projects folder information. So the project priority estimated fiscal year project. Once these projects are submitted into this folder through discussions with engineering and planning and the superintendent, we'll take a look at those operations projects that we've submitted in those folders, and we'll come up with a game plan, if you will, for fiscal year estimated replacement dates. So within those projects is the name and location of the potential project, the existing pipe size, type of pipe and length, the number of service laterals and leaks, replacement pipe size and estimated budget costs, and any additional notes such as the public right-of-way easement or existing project. Here's an example of one of those projects submitted in that folder. This is via La Cumbre in Greenbrae. So although through that 800 foot section of pipe, 12-inch cast iron pipe, not an extensive leak history. However, the section of pipe you see in the right there in that image, that's a section of pipe that we pulled out of the ground. We obviously have some concerns with the condition of that pipe. We're going to want to create a project and we're going to want to put it into the folder for further discussions. Here we have another operations projects folder map. This is in the Strawberry area of Mill Valley. Extensive leak history. 2 of these 7 leaks that are reported on this map had a cost of over $300,000. There were pretty extensive leaks, pretty extensive roadway restoration costs, and pretty significant impacts to our system. When these water main breaks did occur, those 2 large ones, we did see rate of change alarms changes for Strawberry Tank and areas throughout our system. Here we have system-wide main leak numbers from 2021 to 2025. Question came up earlier in the presentation regarding numbers. Here you can see class 1, class 2, class 3 total leak numbers going back to 2021. Overall, this slide shows the number of water main leaks has remained stable year over year. There's no upward trend here, as you can see indicated by these numbers, but this kind of shows some overall numbers based on reported class 1, 2, and 3 leaks. Here's another example here. So the historic industry average AWWA is 25 water main breaks per 100 miles of pipe per year. That's a 12-month period. Approximately 900 miles of pipe, that's 225 main breaks per year. So according to the historic AWWA industry average, the chart on the left, the orange line there at the top shows that 225 mark. The black line below that, the fluctuating black line below that shows our main leak numbers in accordance to the historic average. So we are 40 to 45% below the historic AWWA average. And that indicates, strong system performance despite the aging infrastructure that we see out there within our system. So in summary, in this presentation, water main leaks are an inherent part of a pressurized distribution system. The frequency is usually driven by age, material, and corrosive soils, as we've seen throughout this presentation. Operations and engineering continue collaboration, prioritizing pipeline replacement projects regarding future planning. The district averages 2 to 3 main leaks per week, and with continued investment in rehabilitation to support infrastructure.
Thank you.
Thanks, Mark.
Questions?
Yeah, Mark, Darren, thanks a lot. This is a amazing update on an area of the district that I don't think that, we get that much attention around. We have goals for pipeline replacement. I think we're trying to get up to over 8 miles a year now, maybe pushing closer to 10. And, we've made some effort to prioritize together with planning areas for, more attention with respect to replacement. As we continue with our replacement cycle for pipelines and new materials are being used, would we expect at some point that the leak frequency is gonna decline just based on the renovation of our distribution system?
I mean, that could be expected, based on that. Absolutely.
I think the term at some point is operative in the question because really what we have now is we know hundreds of miles of cast iron pipe that is aging in a way that's hard to predict and failing. So we are going to have to get through that hump that's going to take, years, if not decades. And as you get there, then the older stuff starts to get older, right? So there is a continuum when we think about our infrastructure here of, it's hard to imagine the CIP ever going down. It's just the nature of this infrastructure intensive industry, the nature of Marin with kind of disproportionate industry with all the geography we have here with the hills and the pump stations and all that. So it's a difficult issue for the public to really appreciate the nature of these investments, the ongoing nature. It's rough, but I think we're at a good spot in terms of slowly trying to bend the curve, and that's really the goal. So we aren't behind the game. We're at least kind of catching it and maybe getting ahead of it.
Great, thanks. Yeah, that's important, Ben. The other point that really came up for me watching this was that expanding our distribution system incurs substantial operation and maintenance costs, right? It's not just a one-time capital investment. Any effort we make to expand this distribution system, and we continually have discussions about the feasibility of really ramping up our Purple Pipe distribution network. And we talk about the upfront costs of doing that. We rarely mention what the maintenance costs of that type of addition to our distribution network would be, and the requirements they would place on the district to be able to take on the additional maintenance. So this is an important consideration that
we also get requests, as the board knows, not infrequently to take on private infrastructure. And over the years, we have done that. And I'd say almost without exception, regretting it, when we look back on why did we agree to take that private line that feeds a few folks? Because obviously at some point it was going to fail, and we're facing that now in a number of areas. So that's another consideration of it seems so simple to take on, an existing stretch of pipe here or here or here. It's just easier than having. But there's a cost to all of this.
And of course, that was the history of this district, that they took over like 3 or 4 private water companies.
Right.
And all of them had things like, I remember one of the materials that's infamous here is spiral wound welded steel pipe, spiral welded. It's a Navy surplus. And these private water companies ate it up. They bought it all they could get their hands on. And it has a life of maybe 30 years, something like that. And I would assume we still have pieces of that
We do.
in the system. And another thing to keep in mind is when you make a repair, you're always hooking up to the old system somewhere. You can't rip it all out. So you put this piece is new, but it's hooked to this piece on both ends that's old. So it's just part of life. But your observation is correct. That, it's like a car. You have a first cost of the car, and then you have maintenance.
And then to your point too, Director Russell, when we do make the repair, we're required, our paving requirements for that repair extend beyond.
Of course.
So there is the potential for us to have to go back in there and excavate through that recently paved area.
Exactly, Darren.
Yeah.
Thank you both for the presentation. Appreciate the information, and it's quite a bit of it. To Director Cush's point, it's good to see as a refresh to understand what's going on with that. Besides the fact there's a lot of leaks in Terra Linda area, I did just want to acknowledge and say thank you to the staff, because you glazed over it, but folks staying up all night out there digging in conditions when most of us are enjoying a warm bed sleeping so that we can get water, it's appreciated. So thank you.
Yeah, a great presentation, and thank you for taking the time to walk the board through it, because it is really critical to realize this is the argument against the water being free. Well, it falls on the ground, it doesn't cost anything, right? Yeah, well, this is the other half. The problem of getting it to you 24 hours a day, 7 days a week, 365 is the tricky part. And then thank you guys for the hard work and responding quickly. Public comment?
There are none.
That's unfortunate. I wouldn't normally say that, but I will this time.
Oh, you want one?
Of course. Thank you, Phil.
Thank you. It's a really great presentation, and I hadn't really thought about the maintenance issue being baked into the cost of the project, and there's really no reason to not apply that as the cost of the project up front, as far as I can tell. Just do a net present value of expected maintenance. And the other thing that occurs to me is, if you do put in purple pipe, aren't you relieving some of the load on the existing potable water piping system? Wouldn't you get some payback on the maintenance of that if you had to further maintain the purple pipe system? Just throwing that out there. I don't know if anybody has an answer, but I'm throwing that out as something to look at.
Yeah, we're not supposed to answer things that aren't on the agenda, but I don't think too much of it is wear and tear. It's more just facing the pressure. So whether you route through two pipes or one pipe, the pressure is the same. So it sits there under this, effort where it's being pressed into duty by the water pressure. So, whether it's flowing 10 gallons a minute or 100 gallons a minute, probably doesn't make too much difference to it. One thing I saw that was a little disconcerting was that most of that cast iron appeared to be unlined. Although it's in great shape, which speaks to the corrosion control water quality, because I work with LA Water and Power, and as did my father when he was there. And red water complaints are difficult ones. I don't think people really appreciated what it can look like when it says, think of it as like color of coffee, but bright red or black, depending on the situation. But we're not seeing that. So we're obviously doing a good job with the water of keeping it happy in the cast iron. But it is, again, disappointing. It speaks to my problems with Seeger and that group in the past. They always chose the least expensive route to fix things with like unlined cast iron. And I guess, because I think mortar lined has been around. I started in Montgomery in 75, and we wouldn't put anything in that wasn't mortar lined in 75. So I don't know when that change occurred, probably in the 50s or the 60s.
Chair Russell, we have one more speaker.
Oh, sure.
Grooves.
Sarah Groves.
Thank you.
I've been concerned about the backlog of pipe and the approach of 8 miles a year. Seems like it's going to take a long time to recondition all that 900 miles of pipe. Anyway, so I would encourage everybody to think about more pipe instead of less in terms of the annual replacement. The other thing I think is going to be interesting is when you put in the sonic leak detection system with the new automatic billing system, I think you're going to might well find a lot of new class 3 leaks that you didn't know about. And I think those need to be anticipated. So, but anyway, this is a very impressive performance. I think it's really hard to manage one of these big leaks, and I've been impressed by the efforts that everybody successfully makes. Thank you.
Thank you for your comments.
There are no further speakers.
Okay, thank you. Great job, Mark. Local hazard mitigation plan update. No, the other troublemakers.
Yeah. Good morning, Chair Russell, board members, Alex and I, Engineering Director. This morning, we're presenting the item on the local hazard mitigation program that we have to renew every 5 years as an administrative process. Here to present the item this morning is Alicia Irish, our Engineering Planning Manager.
Morning, directors.
Hi, Alicia.
Hi. So the district's in the process of updating its 2022 local hazard mitigation plan, also known as the LHMP, to evaluate the district's risk to natural hazards and develop mitigation strategies to reduce long-term risk and loss to people and property from natural hazards. Natural hazards such as wildfires, earthquakes, and flooding can cause loss of life, damage to buildings and infrastructure, and severe economic and environmental impacts. This hazard mitigation planning is the process through which hazards and risk may threaten communities are identified, mitigation goals are set, and appropriate strategies to lessen impacts are determined, prioritized, and implemented. This LHMP must be updated every 5 years to remain eligible for grant funding such as FEMA funding through the HMGP or the BRIC program, which you may have heard about. The update to this 2022 LHMP will allow the district to continue focusing resources to address projects that align with the LHMP requirements and reduce the district's risk to natural disasters. Staff plan to return to a future regularly scheduled board meeting in the fall of this year to review the findings, as well as present the plan for consideration of adoption by the board. Following board adoption of this updated LHMP, it will be sent to the California Office of Emergency Services for review and adoption prior to the current expiration in March of 2027. Thank you.
Do we have somebody at the Office of Emergency Services that knows us? Or does it just go into a pile?
There's a contact that we have that we talk with.
So this is noted, sets us up to pursue, you aren't able to pursue these FEMA grants without it. So for example, the clarifiers that we want to repair that are directly linked to potential earthquakes is something we're aggressively looking at for grant funding.
And we should remind folks that the design firm that put those in is the same firm that did Santa Clara Valley Water, who had the failures where these are crossing launderers that collapse into the tank. So it basically puts the clarifier out of service with no launderers.
A quick question on ours. Does ours dovetail into the county's plan or is it a standalone?
It's a standalone plan. The county has a multi-jurisdictional plan. We're a special district and we are electing to have our own plan.
Okay.
And is the majority of the focus on the dams? Or?
Dams are one of them. Dam failure is a hazard that we are evaluating. But we have earthquakes, floods, severe weather, mass movement. So with wildfire, we're kind of running the gamut on all the risks.
One of the exciting parts of having a watershed.
Alicia, it's good to hear about this. I wasn't aware that this is a requirement that we have to go through every 5 years. It's good to know about this. Sounds like a really big job. But what you mentioned to HMG and then BRICS. What are the?
Yeah, so FEMA has a variety of grant funding opportunities, some of which we are eligible to take advantage of, and we have applied through in the past. One of those programs is the Hazard Mitigation Grant Program, also the HMGP. And we have also applied for the Building Resilient Infrastructure and Communities Program, also known as the BRIC program. These are both sponsored through FEMA.
Okay. All right. Well, great. I imagine when we see the updated plan there's going to be scary elements in there because as we think about all the different potential hazards.
It shouldn't be that scary. We've got what we've done, and we know sort of what we're dealing with now, and the plan's going to do a comprehensive review, and we'll come out with some recommended mitigation actions.
Look forward to it.
How many of these have we done already?
The 2022 plan was our initial plan.
First one.
We had not had a plan prior to this.
Yeah. It's fortunate that the ground doesn't change too much. Huh? So, what you found the first time is kind of what you find the
Yeah,
second time.
yeah, yeah. Building upon the first one, sure.
Yes. Great. Thank you. Any questions? Public comment?
There are none.
Okay. Great. Thank you very much. We look forward to, are we doing this in-house or with a consultant?
We're utilizing Black and Veatch for this. They've helped us with a grant assistant in the past.
Good. Thank you. Okay, pipeline extension.
All
Alex is in the hot chair.
I'm still here, and this item will be presented by Rachel Krishner, our engineering services planning supervisor. This is just a kind of a routine pipeline extension agreement for new development that's happening on a road where there currently isn't a frontage of a pipeline there. So here to present the item will be Rachel.
Good morning, everyone.
Good morning.
This is a brief presentation to review and comment to the regularly scheduled board meeting, the Auburn Grove Pipeline Extension Agreement. On June 5th, 2025, the County of Marin approved the subdivision of a 4.95 acre unit of real property to develop 79 units on 2 lots. These units will be constructed within 16 buildings containing a mix of single-family, duplex, and multifamily residences. The developers contacted the district for water service to these properties, and staff was able to determine they do not qualify for water service under our standard conditions as the parcels do not front an existing water main. Therefore, in order to provide service to the new residential development and meet the 1,500 gallons per minute fire flow requirement set by the Marin County Fire Department, an extension of our existing facilities will be necessary. The extension includes approximately 1,150 linear feet of 6-inch water main, 4 6-inch hydrants, 15 4-inch fire lines, 11 1.5-inch services, and 6 1-inch services. The applicant will hire a contractor with the appropriate license to install the facilities. The district will provide the inspection services and all the materials for the project. Just to restate, staff is recommending the committee review and comment to a full board meeting for approval of the pipeline extension agreement.
What is there now?
There is nothing currently connecting
It's
the
a parking lot or it's just bare land?
bare land.
Rachel, I'm not looking at the staff report at the moment. I think there's a map in there, but where is it located?
It's in the Cal Park neighborhood
San Rafael.
in San
Okay,
Rafael.
all right, great. Okay, yeah, that helps.
Cool.
No, thank you for the for letting us know, and I guess we'll hear about this again at a full board meeting.
Okay, thank you.
Yeah.
Public comment?
Yes, Phil Sauter.
Phil, I can guess what this is going to be.
Stay here.
I can guess what you're going to say.
Oh, yeah. Okay. Okay, great. Well, I'm going to say it then. Director Russell suggested recently that we think of laying purple pipe as part of future pipeline projects. And I wonder if this project could be included. Given the current focus on increasing recycled water in California, there may be grant funds available for this project if it were to include a recycled water component. In applying for the grant, I was just thinking out loud, the district could split the recycled pipe component 50-50 between potable versus recycled, or it could split with just the incremental cost of the purple pipe. In the first case, the grant funder could see an effective discount of 50%, and in the second case, an effective discount of perhaps 80 to 90%. It seems to me that should put the district at the head of the line for real dollar impact of grant funding. Thank you.
Thanks, Phil.
There are no further speakers.
Okay, cool. Thank you.
But,
Okay.
sorry, Larry, can I just make one more comment?
course.
Phil's comment, brought up another question for me, which is it the developer that bears the cost for the extension?
Yeah.
Yeah, yes, because they pay for all the upfront costs of all the development of, we provide the material, we take ownership after the fact, but they provide the upfront cost.
Right.
And
Thank you.
it's done to our specs and then it's turned over to us.
Yeah.
Yeah, it's a pretty
Yeah,
good deal.
and that then obviously is reflected in the costs that this type of housing then incurs,
Of course.
Right.
Of course. Plus there's connection fee
Right.
for each of the houses. So, and in areas like Contra Costa County, some of them like Contra Costa Water, the connection fees can be 50 million a year where there's rapid development going on. So it becomes big dollars.
The total revenue for the district based on connection fees.
Yeah. Yeah. Because our fee is what for a house like this, like 35,000 or 40,000.
The capacity charge for this project is 1 million.
Right. And 76
Yeah.
development lots.
Mhm.
So, and then there's a sewer bill too that comes with that, another capacity charge from the sewer side. So you got maybe 100 grand per house or 50, 75 grand per house just for the ability to build it. Plus they'd have to build all the infrastructure and turn that over to the appropriate districts.
Correct.
So that gets plowed into the cost too. And it all goes, of course, to the homeowner.
To the homeowner.
It's like the Trump's tariffs, they ain't paid by the company. They're passed on to the consumer. So.
And we could just keep going. I'm sorry. Are these, I didn't get, are these going to be mostly multi-unit or single family residences?
It's a mix of single family duplex and multifamily units.
Is it lower cost units? Are they?
There is a portion of the units will be affordable housing.
Good.
Yeah, about 16 units.
Good. Okay. Thank you, Rachel.
You're welcome. Thank you.
Okay, cool. All righty. Our next meeting is May 14th. And with that, we'll adjourn.